Hi, everybody. We're going to do 2.1 together. And what you're going to need is your book. Open to page, I believe it's 35, and you can see that it says 2.1. And in your white packet, find where it says 2.1. It's probably somewhere around page 5. I don't have mine numbered, but at the top it says, what is the mean household size? And it says 2.1. All right, so pause this, get what you need out. Again, textbook to page 35, or where it says 2.1, what is the median household size? And then your white packet for now that says, once again, to 2.1, what is the median household size? So, mean household size. All right, so let's focus on this page. All right. 6 students in a middle school class use the United States Census guidelines to find the number of people in their households. Each student makes a stack of cubes to show how the number of people in his or her household. The stacks show that the six households vary in size. So the question is, what attribute is being investigated? Again, what we're looking at here is we're looking at household sizes. So we have Ollie with 2, Pablo with 6, Yarnell with 3 people in his house, Ruth has 4, Gary has 3, and Brenda has 6. How can you use the cube stacks to find the median of the data? All right, so let's take a look. Again, we're trying to think how we can find the median. So what would be our first thing for the median? You're not going to write, I'm just going to write this out. Remember, we have to put them in order size, right? So I have a family of 2, family of 3, 3, 4, 6, 6. Now remember, we have 1, 2, 3, 4, 5, 6 pieces of data. So therefore, half of 6 is 3. So it's going to be between my 3 and 4th piece of data, which is 3.5. Now, that really doesn't make sense. Can you have half a person? But in statistics, it's saying, 3.5 means most houses, it's going to be somewhere, some have 3, some have 4. It's kind of that it's not exactly 3.5 people per house. So another way to find, one way to find the mean or average, okay, so usually when we say, like, I want to find my average, okay, typically we're talking about the mean, okay, sometimes median is called the average, but typically when we talk about the average, we're talking about the mean household. So one way to find the mean or average household size is to make all the stacks the same height by moving the cubes. The evening out of the stacks tells you how many people there will be per household if all households were the same size. I'm going to read that again because that's a super important statement. Because so many times when people ask, well, what is the average? What is my grade average? They really don't have a concept of what they're really representing with the number. And that's why I wanted to take the time to go through this investigation instead of just telling you how to find it. So again, one way to find the mean or average household size is to make all the stacks the same height by moving cubes. The evening out of the stacks tells you how many people there will be per household if all households were the same size. So how can you use the cube stacks to find the mean household for these 6 students? So here are my stacks. I went downstairs and found some Legos. Flip this over. Okay, so we have Ollie's house, which has 2. Let me straighten this out for us. Sorry about that. We have Ollie's house that has 2. We have Pablo's house that has 1, 2, 3, 4, 5, 6. Oops, too many. I'm glad I counted. I'm going to double check that. 1, 2, 3, 4, 5, 6. So that is Pablo's house. We have Yarnell's house that has 3. Okay. We have Ruth's house that has 1, 2, 3, 4. We have Gary's house that has 3. 1, 2, 3. And then we have Brenda's house that should have 6. 1, 2, 3, 4, 5, 6. Good. I counted hers, but it's off the screen. All right, so here are our 6 households, and we still have to keep the 6 households. But what it said about the mean is if we evened out the households. So again, 1, 2, 3, 4, 5, 6 households. What if I even them out? Okay, well, obviously I'm going to need to take from my bigger ones and put it towards my smaller ones. So if I move that, that even those out. Okay, and now I have an even one here. And again, I have to keep my 6 stacks. So I'm just going to take from here, move that at 4. Okay, we're still not even. Now I'm going to take this and place it here. So now if I evened out all of my families, okay, I would have 4 in each of my families. Okay, so once again, we started off all with different numbers, but the mean is showing us if we evened out all of the people in the 6 households, okay, there would be 4 people per household. All right, so again, let's start back and show that one more time. So it's going to be an important concept. I know it kind of seems obvious, but it's something that will be important to us. All right, so again, we started off with our 6 households. 2, 6, 3, 4, 3, 6. And we're finding the mean. Okay, and in order to find the mean, we're going to even out our 6 households. I still need to have 6 stacks. So I'm evening out. That makes 1 there. That gives me 4. Over here is 4. And then I bring 2 here, and that gives me 4. So the mean number of people per household is 4. The mean number of people per household is 4. Okay, turn to the next page, 36. You can also use a table to show the data. So again, instead of having our stacks of our cubes, of my Legos, we have Ollie as 2, Yarnell 3, Gary 3, Ruth 4, Pablo 6, and Brenda 6. How else can we represent data? Well, we know from our last chapter, we could do a dot plot or a line plot. And then which representation tells you how many people are in all 6 households? Which representation tells you how many people are in all 6 households? In this problem, we're going to look at the mean of a data set and how it's calculated. So over today and tomorrow, our goal is to understand what the mean represents and how it's calculated. Okay, problem 2.1a. Please look over also at have your lab sheets in front of you also. And in the first part, it says you can use an ordered value bar graph to find the mean of a data set. An ordered value bar graph and a dot plot are shown below. Both display the number of people in the 6 households found in household size table 1. You already found the mean for people by evening out the cubes. So again, we did it physically, or I showed you physically with the Legos evening out the cubes. But obviously in life, we're not sitting there with stacks of Legos. We're usually going to be given data tables or graphs or line plots or things like that. So we need to be able to interpret those because those are what we're dealing with in real life. So on the left-hand side, we have what's called an ordered value bar graph. Okay, it's done horizontally here, just again to show you that bar graphs don't always have to be vertical. And ordered value, just again, it goes from greatest to greatest. I can speak today. Greatest to least. So if I even take my colors here, that my Legos, I'm going to play with some Legos today. So if we take my Legos, here's my 6. Here was my other 6. Put my red back together. Here is my other 6. Here is my 4. Okay. Here's my 3. Here's my 3. And here is my 2. And this, zoom out a little bit for us, looks exactly like what's on your paper. Okay, where we have in order from greatest to least. There we go. Sorry about that. Okay, we have greatest here to least, so it's in order. And that's all an ordered value bar graph is. Could we have it vertical? Sure. But we're so used to seeing graphs in this way that there's just nothing wrong also, and we want to get you used to, that graphs can go in this direction also. Okay, so we have our ordered value bar graph here. Okay, and then we have a dot plot here. Okay, and the dot plot, I'm going to make that too. Just give me a second. Let me get some more Legos out. And give me a moment. Okay, so here at the bottom, I've made a dot plot, and very similar to what you have on your paper. And again, you could find the mean using the dot plot. It's not a very efficient method, especially when you have a lot of pieces of data, but I do want to show you because the arrow there on the page, if you notice right here, is indicating 4, which we had said was the mean. So in a way to show you how you can get 4 and how you can find the mean from a dot plot, you want to start moving everything towards the center. So what I'm going to do first is take my lowest data value and move it 1 to the right. Then I'm going to move my highest data value and move it 1 to the left, which now jumps here down to 5. Then I go back to my lowest size and move it 1 to the right. And then I go back to my higher side and move it 1 to the left. Back to my lower, move it 1 to the right. Back to my upper, move it 1 to the left. Back to my lower, move it 1 to the right. Back to my upper, move it 1 to the left. And now we notice that everything is stacked at 4. And that's where we found the mean also when we evened out our stacks. So this was a way again. So I had, let's see, 2. Now, is this an efficient method? No, but it's again another way to visually see how we are finding the mean of our data. So again, what I did was lower, move it 1 space to the right. Upper, move it 1 space to the left. Lower, move it 1 space to the right. Upper, 1 space to the left. Lower, 1 right. Upper 1 left, lower 1 right, upper 1 left, and we end up with all stacked on 4. Okay, so again, 2 visuals of dealing with our mean. The one, again, that I like to talk about is how we evened out our stacks and we got to 4. So let's go back to this now. Let's go back to the question they have here, A1. A1 says, explain how the ordered value bar graph and the dot plot are related. So I want you right now, I want to pause, and I want you to, where it says A1, I think for a moment, and how would you say that these 2 pictorial representations of our data are related to each other? Pause here, write your answer in A1. Okay, let's see what you thought and if it matches up with mine. All right, so again, we're asking, explain how the ordered value bar graph and the dot plot are related to each other. Okay, well, if we take a look, each dot on the dot plot represents an endpoint on our ordered value bar graph. So here I have 2. Okay, well, 2, I have 1 on 2. I have 1 bar that ends at 2. Here I have a 3 and a 3, and I have a bar here that ends on a 3 and a bar here that ends on a 3. I have a 4. Okay, bar ends on a 4, and I have a 6 that ends here and another 6 that ends here. So that's how these are related to each other. Okay, let's go on to the next page. And we're looking now at A2. Okay, so Brenda, now we're going to see how we can use this to help us find the mean. Again, sometimes we're given visuals, and we could use these visuals instead of doing things numerically. So Brenda used the ordered value bar graph at the right to identify the mean. Her first steps are shown on a copy of the graph, which you have in your workbook. Complete Brenda's steps. So Brenda's first step, again, her goal was she wanted to identify the mean, and her first step was to take this piece and she moved it down and put it here. Okay, so maybe if you want, you can say, okay, she took that piece off and she colored it over here. So I want you to complete this graph, very similar to what Brenda did, okay, and to represent what I did with the Legos. So what you're going to do that is you're going to do that here. So again, we'll start off with the first step that was done in the book, which was Brenda took this piece, this length of one person, and we're going to take it, and if you want to draw the arrow, or we're placing it down here. Okay, so we took that one person and we put it down in Ollie's family. Okay, so finish this, pause the video here, and finish evening out, just like I did with the Legos, but now we're going to do it on a graph. Go ahead, pause the video here. So what you should have done if you're not sure is, again, I took another one of, so I took one, I put it here. Maybe I'll take the next furthest one, and Pablo, and put it here. Now I have 4. Okay, then I have 1 here, and I could take another one from Pablo, and I still have here. I want to even out. Remember, my goal is to even out my stacks by still having all these 6. And I'm going to take this and put it here. So again, just like my Legos, I have now evened out so that all families have 4 people in them. Okay, so that would be A2. Now let's look at A3. Ollie says that after evening out the bars, the graph looks like 6 households with 4 people in each. How might you have predicted the mean? Explain. This is a little deeper thinking, and again, it's something that you feel. Ollie says that after evening out the bars, the graph looks like 6 households with 4 people in each. How might you have predicted the mean? And explain. So go ahead and fill in A3 over here with what you think. I will pause the video. Okay, so answers may vary on this, and it might be hard for you. Some of you, again, your answer just might be that you need to physically move the bars, okay, and that's perfectly fine. Or that you may physically still kind of need to ingest that we have, again, our 6 physical households here, and that I need to physically take them and move them around. Okay, and if we don't have our physical aspect of it, you have the picture of it. Okay, so again, here was my ordered bar graph in my three-dimensional Legos, and I was able to physically move these pieces around, these family members around, okay? And that could be, again, physically moved by doing the bar graph. The other way some of you might have come up with is, oh, well, I have, okay, turn it this way so I have more room. Well, I have 6 people here, 6 people here, 4, 3, 3, 2. How many people do I have that I need to break up into my 6 households? Oh, well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, I have 24 people. And I am taking those 24 people and I am evenly distributing them because I'm evening them out. So I'm evenly distributing them into my 6 households. Oh, I have 4. Does that sound right? Okay, 24 people that I am breaking into 6 households, and I'm missing a person over here. This one wanted to stay for dinner. Come back home. Okay. And we are breaking them into these 6 households. So keep that in mind as we keep going on. All right. So again, some of you might have just said, you know what? I needed to physically move them around. I need to visually see it. And some of you might have been like, oh, there's 24 people, and I'm sharing them among 6 households. All right, moving on to the last part. Oh, I know what I did. I made a mistake on here. I forgot about this. We're going to cross out these boxes, B2 and C2. There was a mistake, and you're going to go on to the next page of this. So cross out B2, cross out C2, and this should be the page that you should be on. Okay, and it says B1 at the top. And you are going to move on to B1 here. Okay, so here it says, another group of students made the table below for different sets of data. So what you're going to do is now you're going to work through B. And you actually, if you want to pause it here and work with your table mates, that's fine. You're going to make an ordered value bar graph and a dot plot of this data. Okay, and I've given you space for that here. Okay, then you're going to find the mean of the data, explain how you found it. You could choose any method that we just went over today. How does the mean of this data set compare to the mean of the of the data in question A. So again, that's what we just did on the page before, okay, with our 6 households. So you're going to be coming back to A. How does identifying the mean on an ordered value bar graph help you find the mean on the dot plot? And then how does knowing the mean help you answer the question, what is the typical household size? So again, if you want to look at people around at your table and see if they're at the same point here, which they should be, and you can work through B together and then go back to Schoology and see what would be next on your list.